Hello and welcome to Sean White's Solar and Energy Storage Podcast. Okay, here we are doing another podcast, and today we have Kane Kuharik, and Kane works for SunGrow. So I guess the sun makes things grow. Are you doing some kind of farming or something like that with SunGrow?
That's exactly it, actually. Yeah, we are.
Farming in the sun. Yeah, so I guess the sun comes down, it's electromagnetic radiation, it's photons, and then it hits things. And the old-fashioned way of making energy was you had sunlight hitting chlorophyll molecules and bouncing an electron around and somehow turning that into, the macros, they call them. You got carbohydrates, proteins, and fats. And now with our better technology, we have it hit a silicon crystal. And then that silicon crystal puts an electron out in the band gap. And then it takes that electron and then it turns a computer chip. And then that's what makes the whole world go around. Server farms, AI. And so after that, we don't need carbohydrates anymore. And we don't need plants. This is, humans. We don't need all that stuff anymore, right?
Well, at this point, electrons are truly, what power SunGrow as a whole, right?
Yeah.
Our entire business model is based off that. So,
I'm just kind of messing around, and you guys make the things that, not really the crystal part that's capturing the electrons. Then it goes through this magic box, and it turns direct current into alternating current. That's what you specialize in.
Yeah. So to give a little bit of background, SunGrow basically has two main product lines, if you want to call them that, in the US. One would be our PV inverter team, which is what you're referencing, right? The inverter. And then the other product line would be battery storage, which is what my team focuses on specifically. However, we, work cross-functionally, PV and BESS teams.
So batteries are better than PV then, right?
It's essentially what I'm saying.
Yeah. Okay. Yeah. And I know that you're smart because I was looking at your LinkedIn profile and you used to run SLAC, or you worked at SLAC.
Yeah. Did about a year or so at SLAC and worked.
And so I toured it, and
it was projects there. It was fun.
It's a really long, skinny building. So I guess that means it has a lot of surface area. How long is that skinny building?
I'm not actually sure because I worked fully remote during the time that I was there. I never had the opportunity to go into the lab.
Okay, so I went and took a tour. Maybe you could tell people what SLAC is. I guess they know how to make electrons go really fast.
Yeah, so SLAC National Accelerator Laboratory is essentially a lab that focuses on a number of different things, but it's essentially primarily focused on promoting new innovations. And what I was working on back then, a number of years ago, was developing at that point, an algorithm that was machine learning for the most part, and basically trying to identify the locations on the electric grid that were best suited for upgrades on the transmission lines, right? So if there was an area that was particularly constrained, is there a way to identify which areas that would be and which equipment needs to be updated most efficiently? Those were the projects that I was working on.
Okay, that's very interesting because I always think of SLAC as being like an accelerator, and they're famous for knowing how to make electrons go about the speed of light.
Yeah.
And so that's why it had to have this really super long building. And so SLAC, as we all know, stands for Stanford Linear Accelerator Center. And it's got this 2-mile long building. And it's just like a narrow building, and it's really long, and it's kind of cool. And if you're ever in Silicon Valley, where all these smart people like to hang out, you can go there and take a tour like I did. So I know we're supposed to be talking about inverters, and I'm taking you on a trip down a very narrow building and over there in Menlo Park, where Stanford is. But let's talk about your energy storage inverters. That's probably a good topic.
Yeah, absolutely. One thing about my group is we're focused on the commercial and industrial sector of the market right now. And what we're doing is a lot of cool stuff, but we're really focused on pushing out a new product to the market, which is called the PowerStack 2.0. And it's essentially SunGrow's all-in-one commercial and industrial energy storage system. It delivers 125 kilowatts and 255 kilowatt hours of usable energy capacity in a single box. And the one message I'd like to really emphasize is that, it's designed for real world commercial and industrial applications like commercial buildings, warehouses, EV charging, right? Where customers need demand charge reduction, grid support, and resilience. And those are, some of the main applications that we see from this battery storage solution that we're pushing out to the market here in 2026.
Great. So you're working in the commercial and industrial, the C&I part of the industry, but I believe that SunGrow makes inverters and battery storage for like huge projects, right? Like they also
Yes,
have those, but that's just not what your job is.
absolutely. We range all the way down from, the kilowatt hour range all the way up to the gigawatt hour range. So
Wow,
my
gigawatt
team
hours.
focuses specifically on commercial and industrial applications, but we
Hmm.
do have larger utility scale teams who deal with the much larger projects that get a lot more complicated and intense.
Okay. And so are you mostly working in the United States?
Yes. So my team covers all of what we consider North America is all of the United States and all of Canada. We have a Latin American team that covers Mexico on down.
Hmm. Great, great, great.
This podcast was brought to you by Air. Take a breath and experience air yourself. Don't forget to breathe.
So where can we learn about the SunGrow energy storage inverters for commercial and industrial applications besides listening to this podcast? I guess you're on your
Yeah,
website.
absolutely. So we obviously have a website. You can go to sungrow.com and it'll take you right to the North America page where you can filter it down from utility scale applications all the way down to commercial and industrial applications. Or you can reach out to myself. I am the director of the sales team for North America here and would be happy to collaborate with, folks who are working on projects or just curious about the industry. We have a lot of materials that we're willing and able to share with customers or, folks of the industry. So feel free to reach out to myself or, we have a lot of great material online.
So what are you usually selling when people are getting a commercial and industrial energy storage system? Is it something that goes outside of the building, inside of the building, combination of both?
Yeah. So our PowerStack 2.0 is rated to be placed outside, so outdoors.
Hmm.
Essentially, you need to be around like 5 to 8 feet away from any like building or wall to allow for adequate airflow. But you can put these anywhere, right? You can put
Hmm.
them on a concrete pad. You can put them in a parking lot, anywhere, around your site that you have some space and easy access to, I guess, the distribution panel where you can plug in a couple of the wires that would actually get it charged and connected to your plant.
Okay, great. So you put it outside, 5 or 8 feet away from the building. And how big is it? And do people usually have multiple, like a series of them? So like
Yeah.
compared to a container, maybe something like that?
Yeah, what most people are used to when they think of battery storage is a standard 20-foot shipping container that you see on the back of a semi truck, right? This is not that. The Power
Hmm.
Stack is essentially a 5 foot by 4 foot by 8 feet tall.
Hmm.
So you can think of it as like a really big industrial refrigerator if you want to get a sense of scale right there. And you can essentially stack several of them in series next to each other. So I think what we're pushing for right now is customers are taking a look at individual units themselves, but also pairing together 1, 2, 3, 4, 5 units. And if their load grows over the years, they can add more, right? That's the best thing about these units is they're easy to deploy. They can be moved around with a large forklift, so you don't necessarily need a crane to operate or move these. And they come pre-commissioned, right? So a lot of the testing is done at our manufacturing facilities, and it's essentially one box that comes to site, and you plug it in to your distribution panel, which would be 480 volts.
Hmm. Great, great. And so, yeah, they're a lot smaller than a container, and you can move them around with a forklift. And you said you stack them, and that means you put them next to each other, because if you stacked 8-foot energy storage systems on top of each other, that would be kind of tall.
Yeah, I misspoke there. So we wouldn't necessarily stack them on top of each other. We would put them side by side. You can put them side by side. You can put them back to back. You can put them facing each other. A lot of different configurations depending on your site and the space that you have. If you have like a 20-foot by 5-foot lot that you are restricted to, we can make it work. It's just a matter of getting with our engineering team and coming up with the solution that would work for the end user's needs.
Great. And so when somebody wants to get one of your energy storage systems, then you do a lot of the engineering for them?
Yeah. So what's great about this unit is that in the past, commercial and industrial battery storage has always felt like a custom project every single time, where folks would have to come to us. We would do refined engineering efforts and a lot of field integration that puts, essentially the schedule at risk. But with the PowerStack, it really simplifies these efforts, and because a lot of it is factory integrated, right? We have a built-in PCS, no external equipment. That means a lot faster installations, more predictable commissioning you're going to see, and then, overall just fewer surprises for developers, HJs, or owners. Yeah.
Okay. And let's define PCS.
It would be a power conversion system.
Power conversion system. Because also we have something in the National Electrical Code called power control system. And so it gets a little bit confusing. And a power control system is a type of energy management system that could control currents on conductors. So you could avoid burning up a conductor, with too much current. And so that would be something too, where like if you had 10 EV chargers, and you could send, and then there's like one car there, you could fully charge that one. But if there's all 10 of them there, maybe you'd have to have them turned down a little bit to handle all that. And I bet you guys work with power control systems too.
Yeah. And I'm glad you mentioned that, right? Because we do have EMS providers, energy management system providers. But the good thing about PowerStack is that it's not contained within the unit itself, and we're agnostic to EMS providers. So end user has a specific EMS technology or software that they are comfortable with and have been using for years at different sites. We'd be happy to partner with them, and we have a lot of trusted partners that we collaborate with. So the good thing is that we are agnostic to the EMS provider, and as long as you have someone in mind, we'd be willing to work with them.
Yeah, it's funny how there's so many different initials for things like energy management systems, emergency medical services, power control systems, power conversion system. Yeah. And then there's also electronic power converter, EPC. And then that means engineering, procurement, and construction. And so power conversion system in the National Electrical Code is kind of switched over to EPC.
Exactly.
Electronic power converter. So, hey, what do you know? Lots of crazy things that a lot of people call acronyms, but an acronym is supposed to spell something like that you could sound it out. And so we don't go EMS for EMS. That would be like trying to turn EMS into an acronym instead of an abbreviation. But anyway, I just think all this stuff is kind of interesting.
Absolutely.
So remind me, how many kilowatt hours are in one of your energy storage systems?
Yeah. So for the PowerStack, it's rated at 125 kilowatts, 255 kilowatt hours per
255 kilowatt hours. So that could be something like 3 or 4 electric vehicles.
Yeah, it could be.
Yeah. I just kind of one way of looking at it, like that's how many batteries are in there. Yep.
Exactly.
And then maybe we could put some wheels on it, and then sometimes
put a little steering wheel on top.
Yeah, I've heard too that it's like when people start comparing energy storage systems to electric vehicles, they're like, oh, maybe we should just get the one that has wheels on it, And then there might be different tests that you have to go through with an electric vehicle, and you could put it closer to 5 feet from your building, all these different things. So maybe you should just start putting wheels on them,
It could be, in our pipeline down the future, in our
Uh-huh.
roadmap.
Yeah, put it in the garage, all that kind of stuff. So, we're just kind of having fun here. And so I guess like maybe you can tell us a little bit about like some applications that you're doing in real life, like some of the jobs that you have. Like you don't have to tell the exact name or where it is.
Yeah, yeah. So we have a number of different projects being rolled out this year, which we're really excited about. We just got our official UL certification to be sold in the United States back
Hmm.
in October of 2025. And then we're able to sell units shortly after. And we have our first deployments coming out in April of this year, which we're
Oh, great.
excited for, and to see them, fully installed and commissioned. A number of different projects are coming about. A lot of hot markets are hitting the streets in 2026. Mainly California is a big one,
Uh-huh.
of course,
Sure.
Texas as well.
Hmm.
And then we also see, Illinois and New Jersey coming up with some demand response programs that would enable incentives that could make the economics for these battery systems just a little bit more attractive to folks who are going to finance projects. So developers are really excited in those markets as well.
Great. And I guess, everybody's been complaining about the solar tax credits. You don't have to worry about that.
That's exactly right.
Uh-huh.
We're not impacted by
So you
those
still
tax
have like
credits.
a 30% investment tax credit for quite a while now, I guess. Yeah.
Yeah, that is still in place for the US market.
And so that probably makes things a little bit better for you because people are, instead of being upset that the solar tax credit is going to wear out, then they could just, start spending all their money on, stationary energy storage systems.
Absolutely. Yeah,
Uh-huh.
we've seen in the past several years that a lot of battery storage developers are taking advantage of the investment tax credit. So we're happy to support them in developing those projects. And it's, a really good incentive that allows battery storage to be deployed at scale, right? And really fasten the pace, I guess you could say, and make sure that these assets are getting out into real world applications.
hmm Okay, great, great. And how many can you stick together? I mean, do you have like for spacing and things like that? Is there like you go a group of four and then you have like a certain space between them, something like that?
Yeah, so it really depends, but you can get really creative with how you space them out. If you want to do one long line
Uh-huh. Like
of
the
battery storage
SLAC,
system, yeah, right,
uh-huh.
like Slack.
2 miles
If
long.
you, if you want to do one long string, you could essentially put 25 of them in series and create one large battery. At some point, there's a gray area, right, where the economics might make sense to go towards one of our utility scale products just because it's getting so large.
Hmm.
So, at a certain point, the economics step towards moving up to the utility scale. But we would obviously advise you on that and make sure that
Okay.
you're getting the best bang for the buck for our battery storage systems.
Okay, cool. So there's not a limit to how many you can put next to each other. Like I guess, there's the tests or, UL 9540 for an energy storage system. And then there's large scale fire testing, UL 9540A. And a lot of times with UL 9540A, it'll tell you like if you could put a certain amount together and then you have to have some space between them like that. And so I guess you don't have any limitations on how much space you need or like how many you can put in series. You said you could put 25 right next to each other. Yeah, so pretty cool.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
And where do you think would be where you might draw the line where say like, okay, time to go get the big ones, like so get a big SunGrow container style, 20 or 40 foot container size of an energy storage system.
Yeah, so our two utility scale assets would be the Power Titan 2 and the Power Titan 3. And Power Titan 3 just was released last September, and we're currently taking orders and will be deployed in 2027. However, the Power Titan 2 has been the workhorse for SunGrow for the past several years and is what, we typically push out into the market just because customers are comfortable with it and they're used to seeing that asset. The Power Titan 2 is a 5 megawatt hour block. So you can fit 5 megawatt hours in a single container.
And so that's like a 40 feet long.
That would be a 20-foot container.
Oh, 20 feet long.
Yeah,
and
20-foot container.
8 feet wide, 8.5 feet tall. That's a
correct
container size. Yeah. Great.
Exactly. And then that same container, right? If you're looking at the Power Titan 3, you can fit 6.9 megawatt hours. So
Wow.
1.9 megawatt hours more. And that's, mainly due to
That's a
the
lot.
increased cell density that we see.
Mm-hmm. It sure is a lot more than it used to be, like how much you can fit in one of these containers. So
Yeah, it sure is.
technology is getting better. And I guess it's not only, they're getting better at making batteries, but the cooling systems and the access. It used to be that you would walk into this container and there'd be batteries all around you. And now you access everything from the outside. It's safer, so you can't get trapped in there. Yeah.
Exactly.
Mhm.
Everything, we have doors lining the outsides, and we have a fully liquid cooled system. So it's much more efficient and allows for safer operation, which we're excited about and happy to discuss with anyone who is interested.
So the C&I energy storage system that you're working with, it's liquid cooled, I guess?
It is liquid cooled, yes. Same sort of technology that you see in our larger Power Titan series is going to be integrated into this smaller package, I guess you could say.
And I am assuming everything these days is lithium iron phosphate, LFP?
It is, yes.
And are you using like cylindrical, pouch, prismatic cells?
They are all prismatic cells.
All prismatic cells. And do you know how much energy is in one of the cells? I know the cells are getting bigger and bigger.
Yeah. So for the PowerStack and the Power Titan 2, we're looking at 314 amp hour cells.
So that would be like 314 amp hour times 3.2 volts for lithium iron phosphate. And we've got pretty much a kilowatt hour, 1.0048 kilowatt hours. So these cells are getting bigger and bigger. I don't know when it's going to be too big. And then is there anything else too that you want to talk about in particular?
Yeah, I would say, one of the biggest misconceptions when it comes to commercial and industrial batteries is that customers are buying them mainly for backup power. And that's just not the case anymore. Developers are really, purchasing these assets as, first and foremost for cost control and grid restraint. And they're operating more as a financial asset rather than a grid asset, if you kind of think about it that way. A lot of the applications that we're seeing are for commercial real estate investors, EV charger infrastructure, and logistics and warehousing. Folks are constantly trying to cut down on their demand charges. So we're actively looking at, deploying these assets at those facilities to help those customers solve those everyday problems. And that's what we're really trying to help educate the developers out there to understand the real world applications there are for the PowerStack and how you can use it as a financial asset and actually use it as a revenue generating asset rather than just backup power.
Great. Yeah. A lot of people like distributed energy. And so that means that you make the energy where you use it. And if you're turning things on and turning things off all at once, you might have to start drawing a whole bunch from the utility. Or if the sun comes out all at once, you have like all this extra electricity, you have to send it to the utility. And instead of doing that and using those utility lines and getting demand charges, because when you are using a lot of electricity all at once, that's a demand charge, you can use that energy storage system to kind of even things out. And that's the future. And that's how we're going to deal with it. And those same electric lines that we're using could, I think, probably put, 4 or 5 times more electricity on them if we could just send that electricity in a more constant stream than peaking out all at once. So just like, big peak at noon for the solar going out, big peak in the evening when everybody turns everything on all at once. We use the energy storage system to kind of even things out. Another thing that's kind of interesting, I don't know if it's a commercial and industrial application as much, and it's kind of a future thing, and I don't think there's really a way to make money from it in the United States yet, but are grid forming inverters. And so we have grid forming inverters are getting kind of to be a big thing in some countries like Australia. And when there's such a great amount of electricity being made with inverters for like solar and wind, we still need to have that inertia with a big spinning thing to keep the grid going so it's stable. And we can duplicate that with synthetic inertia with grid forming inverters. So that's another exciting technology that I'll expect to see in the future.
Yeah, absolutely. And our team's already exploring that
I'm
with
sure.
a number of different developers out there, right? That keeps on popping up as, a hot topic.
Uh,
And we're eager to support, and it can definitely be done. It's just a matter of, getting the right people in the room and,
yeah.
figuring out the correct application that the developer is looking for.
Yeah, and we have to get the politicians in on it because they have to make the policy with the public utilities commissions to pay people for offering these services. So it's not like people are going to pay extra for an inverter that can do all these neat things that they can't use.
Bingo. Right.
So maybe we'll come back and we'll have this talk again in a couple of years and we could talk more about that.
I would love that.
Yeah.
That'd be great.
Great. Okay, Kane. Well, it's been very good talking to you. And I think I've seen you before. If we met at a solar show, I think you seem familiar, but
I don't think so.
Yeah.
I've only, been in the energy storage world for a couple years now. I was in offshore wind for a while, and I was working with transmission distribution equipment for a number of years before that, but just recently stepped into solar and energy storage.
okay. Well, thank you so much, Kane Kuharik of SunGrow, telling us all about your commercial and industrial energy storage systems. And I think we learned a lot today. So thanks a lot. Thanks for joining us.
Thanks so much, Sean. I appreciate you having me on.
All right. And thanks everyone for listening to Shawn White's Solar and Energy Storage Podcast. To find out more, go to SolarSEAN.com and learn all about energy storage and solar and get yourself NABCEP Energy Storage Installation Professional Certified. Go to SolarSEAN.com/ESIP.